Welcome to The Explainer. Today, we're strapping right into the flight deck of the Bombardier Q400 to tackle something absolutely crucial. It's something every aviator, and honestly, every single professional out there who relies on complex systems, really needs to hear. We're focusing on how to master non-normal situations, and we're going to do that by analyzing real-world mistakes. Because, when everything is totally routine, flying is an absolute breeze. But when an alarm suddenly starts blaring at 30,000 feet, well, that's when your true mettle is put to the test. So how exactly do we conquer complacency and make sure we are 100% ready for a cockpit crisis?
Okay, let's dive into this. Here is our roadmap for today. We'll start with the technology complacency trap, then look at two Q400 case studies covering cabin smoke and pressurization failure. After that, we'll break down the 5-step action sequence and finally wrap up with how you can be the ultimate barrier.
Section 1. The technology complacency trap, when good tech creates bad habits. Modern commercial aviation has this really fascinating paradox going on. We have this incredible, mind-blowing technology, right? But it can actually degrade our foundational piloting skills. To understand why, we've got to look at a concept called mean time between failures. Basically, modern aircraft systems are incredibly rugged, meaning the time between things actually breaking down has gone way, way up. And obviously for safety, that's a massive positive. But it kind of has a dark side. This extreme ruggedness can cause a really dangerous level of pilot complacency. I mean, when systems work perfectly 99% of the time, it naturally leads to an overdependence on that technology. You start getting this cozy, false feeling that, hey, nothing's going to go wrong. And before you know it, your raw piloting sense begins to degrade because you just aren't constantly anticipating failures the way pilots had to in the early days of aviation.
And here is exactly where it gets risky. This brings us to a super easy memory trick I want you to lock in right now, the 6-12 rule of training. In modern commercial airline operations, we simply do not get the daily opportunity to practice flying with degraded systems. You're only getting simulator training once every 6 months, and ground training just once every 12 months. That is a really, really limited window to practice dealing with a total system meltdown. So what's our essential tactic here? We have got to learn from the mistakes of others so we don't end up making them ourselves.
Section 2, Q400 Case 1, Cabin Smoke, a 10-minute crisis in the cruise phase.
Now, what's really interesting about this case is that it's a real-world crisis that kicked off right in the middle of the cruise phase. Picture this. You're cruising along smoothly in the Q400. Out of nowhere, the lavatory smoke warning tone triggers. The pilot in command gets word that there's smoke in the cabin, and slowly, that smoke actually starts seeping directly into the cockpit. The source? Completely unknown. No idea where it's coming from. The pilot in command rightfully jumps on the radio and declares a mayday. From the exact moment that emergency is declared to the moment tires touch the runway, they have approximately 10 tenths high-pressure minutes. Literally every single second counts.
So let's look at what actually happened versus what should have happened. The cockpit voice recorder revealed a pretty major breakdown. The flight crew discussed their memory actions, sure, but they delayed actually performing them. They only did the memory items of the non-normal checklist, the NNC, and then just stopped. They didn't proceed any further with the critical read and do items. They didn't even make a passenger PA announcement. And to top it off, they ended up evacuating everyone out onto an active PAXI track. Now contrast that with the actual standard operating procedures. First up, they should have done the tests briefing for the senior cabin crew. That's a crucial mnemonic trick to establish the type of emergency, evacuation plan, special instructions, time remaining, and signals. They needed to hit those immediate memory actions, followed entirely by the read and do checklist. They should have made that PA and then evacuated safely if it was actually required.
So, looking at this massive gap between what the crew actually did and what the standard operating procedures demanded, I want to ask you directly, where did the crew go wrong? What really caused this total breakdown in the flight deck?
Section 3, Analyzing the Smoke Response. Let's understand the why behind those errors. We're going to thoroughly dissect the technical realities here. First off, the actual culprit. The smoke was caused by leaking engine oil seals. These seals failed, and it sent oil vapors directly into the cabin right through the aircraft's air conditioning system. And here is the absolute tragedy of this whole incident. If the crew had just continued performing the fuselage fire, smoke or fumes checklist completely past the memory items, in all probability, it would have totally stopped the smoke from entering the cabin in the first place. To prevent you from ever making this kind of mistake, I want you to memorize this really simple, powerful framework. Be a super rapid killer of risk, or SRKR. This is your definitive 4-step sequential action plan for any smoke incident. Step 1, secure yourself. Get those oxygen masks on immediately. Do not wait. Step 2, recover the aircraft at the earliest opportunity. Step 3, kill the source of the smoke by actually running the full checklist. And step 4, remove the smoke. The checklist literally guides you to reach a safe altitude, open the outflow valve, depressurize the cabin, and flush all that smoke out. The crew in our case study totally failed to execute these sequential actions. So the crucial point is this: the crew's decision to land at the earliest possible moment became completely overbearing. It totally blinded them at the direct cost of actually doing the smoke removal, even though they had 10 full minutes to work the problem. This reflects a really poor understanding of checklist actions. Because they didn't remove the smoke, they panicked and felt forced to do an emergency evacuation right there on the taxiway. And the ripple effect? 9 other aircraft had to divert just to allow this plane to land on the opposite runway. It was a massive operational disruption, all caused by missing the basic fundamentals.
Section 4, Q400 Case 2, Pressurization Failure, the danger of accepting the unacceptable.
And this brilliantly illustrates our next point. It highlights the serious danger of accepting the unacceptable while you're still on the ground and then paying the ultimate price for it once you're up in the air. Here's what happened. The pilot in command accepted the aircraft for flight while a fuselage door's warning light was clearly illuminated. Unsurprisingly, right after takeoff, the auto pressurization mode completely failed. The pilot then tried to use manual pressurization, but failed to actually do it correctly. The result? They lost total control of the pressurization and had to divert the flight. The desired action instead? Never, ever accept a flight or conduct a takeoff with a warning light on unless a specific minimum equipment list, or MEL, is invoked. And if you do somehow end up in that situation, you absolutely must know how to use the manual pressurization correctly to regain control. Because here is the raw technical reality of the Bombardier Q400 systems that this pilot completely missed. When the fuselage door's warning light is illuminated on the ground, the auto mode of pressurization simply will not work in flight. That's not a bug, that is a deliberate system design feature. However, the manual mode continues to operate perfectly fine in this scenario. So why on earth did they divert? Well, it came down to insufficient skill and a complete lack of understanding of the basics. Manual pressurization is something covered extensively in technical classes, right? But when it came to the actual application of that knowledge under real pressure, the pilot failed. This wasn't a mechanical failure that forced the diversion. No, it was a human failure. And let me tell you, it caused major flight schedule impacts, damaged the company's image, and resulted in some really heavy financial losses. Section 5, the 5-step action sequence. This is your framework for non-normal situations. Let's move to the solution and see how this all builds together. We've seen the mistakes, now let's build your foolproof framework for handling literally any non-normal situation seamlessly. I want you to memorize this incredibly powerful trick. I usually make decisions properly. IUMDP. Next time an alarm goes off, run this exact 5-step sequence. First, I, identify the problem. Second, U, understand the situation by looking at all the associated indications. Don't get tunnel vision on just one light. Third, M, execute your memory items immediately. Fourth, D, discuss it with the other pilot. You aren't alone up there. And fifth, P, perform the non-normal checklist fully to completion. Honestly, if the crews in our case studies had just used IUMDP, neither of those incidents would have escalated the way they did. Supporting that framework are these critical rules of the cockpit. First, you absolutely must utilize crew resource management. Your flight deck team is competent. Talk to each other. Discuss the indications together before you just start rapidly flipping switches. Second, never deviate from your standard operating procedures or the Quick Reference Handbook unless safety absolutely, unequivocally demands it. And finally, you have got to be deeply familiar with all QRH objectives. You should not be reading a checklist for the very first time while you're in the middle of a screaming emergency. Deep familiarity is what ensures your peak situational awareness. Section 6, be the ultimate barrier, moving beyond checklists. Which brings us to our absolute most important point today. The harsh reality is relying too much on checklists without having a basic, foundational technical understanding of your aircraft, it just doesn't yield desirable outcomes.
As we saw, the rugged modern systems handle the normal, everyday, routine stuff beautifully. But when things go wrong, you have to be able to assess the true impact of a failure on the safety of your passengers. And remember this terrifying but frankly empowering truth? There is no IT help desk or technical support up in the sky. It is literally just you, your crew, and your machine. And that leaves us with this final, truly provocative mandate directly from the source material. Be a barrier between an occurrence and undesirable outcome. When an alarm triggers at 30,000 feet, your intervention, your training, and your knowledge are literally the only things standing in the way of a disaster. So ask yourself right now, the next time a system fails, are you going to be a passive passenger relying on automation, or will you step up and be the ultimate barrier? Thank you so much for joining me on this explainer. Keep learning, stay sharp, and fly safe.